that angle 1 and angle 2 are supplementary. Supplementary means their sum is 180 degree. So this question is easy, right? If I just call it angle 3 and I call it angle 4, right? So since PA is a tangent at point A, right? So therefore we will say that OA is perpendicular on PA. Please write the theorem. What is the theorem? That tangent is perpendicular to the radius through the point of contact. And therefore angle 3 is 90 degree, right? Now similarly also PB is a tangent. So therefore OB is perpendicular on PB. Again you write the theorem. And therefore we say that angle 4 is 90 degree, right? Okay, now you come to the quadrilateral. Just a minute, Hamna is also joining. Yes, hello Hamna, can you hear me? Yes, anyway Hamna, I have started question number 10, right? So please see here. So basically in this question, if you read it. So according to this question, you have to show that angle 1 and angle 2 are supplementary, right? So we are just doing, which we have already done in so many questions. So one by one, we are taking a tangent and the radius is perpendicular and therefore angle 3 is 90. Similarly, angle 4 is 90. Okay. Now you come to quadrilateral. So in quadrilateral, this OAPB, we use angle sum property. So angle 1 plus angle 4 plus angle 2 plus angle 3, it is 360 degree. Why? This is angle sum property of quadrilateral. Right? Now angle 3 and 4 are 90 degrees. So you can put here angle 1 plus 90 plus angle 2 plus 90 is equal to 360 degree. So angle 1 plus angle 2 plus 90 is 180. So angle 1 plus angle 2 is 360 degree minus of 180 degree. And angle 1 plus angle 2 is 180 degree, right? So therefore angle 1 and angle 2 are supplementary. Yeah, supplementary.
Instead of proving that both angle 3 and 4 are 90, can we just prove one and state the other is similar?
Sorry, I didn't understand. Say again.
In this, like, can we prove angle 3 is 90 and just can we write similarly angle 4 is also 90?
Yes, you can.
Okay.
I mean, similarly also you can write like this also, by the same theorem, because you have already mentioned the theorem once, right? So by the same theorem, angle 4 is also 90. That way also you can write.
Okay, ma'am.
Ultimately, your teacher should understand that from where you are arriving at it. That's the point, right?
Yes,
Okay.
ma'am.
Right. So this question is over. Let's move to the next question now. Okay, so prove that the parallelogram circumscribing a circle is a rhombus. Okay. Circumscribing means you have a circle, right? And okay, circle with O. So the four sides are actually, touching the circle. So there's a parallelogram like this. Please, if you can make it a better, somewhat better than mine. Anyway, so you have to prove that now this quadrilateral is actually a rhombus, is a parallelogram. So it's already a parallelogram according to the question. So I think it should look like a parallelogram at least. So now if I just draw it a bit properly, so it will look something like this, right? Okay. So these are the 4 point of contacts. Let's give them some name. P, Q, R, S. And then you have a parallelogram, which is A, B, C, D. See, in the question, it's already written parallelogram, right? So you don't have to prove that the sides are parallel. It's given. So what is given here? You have a circle with center O, right? Okay, and then there's a parallelogram which is given. So a parallelogram, there's one L here. ABCD. Okay. So it is circumscribing a circle. So you can write that it is touching the circle at points P, Q, R, and S. So, I mean, it's a parallelogram like this, that it is touching the circle at points P, Q, R, S. Okay, now to prove that it is a rhombus. Okay, so if you have a parallelogram, so how will you show it's a rhombus?
Ma'am, any two of its adjacent sides equal.
Any two. I mean, it's any two are equal in a rectangle also. Okay, adjacent sides.
Adjacent.
Yeah. Okay, that's right. Either all the sides are equal or any two adjacent sides are equal. That we can do here. Hmm. So basically, I mean, we can show that all the sides are equal. Then also it's a rhombus, right?
Yes, ma'am.
Because the see, parallelogram are of 3 types, if you remember. So there are 3 types of parallelogram you have studied, right? Just a recall. So one is a rectangle, and then you have a rhombus, and then you have a square. That's it. Okay. So anyway, when you start the chapter, quadrilaterals, So it's not a part of this question, just revision. So quadrilaterals basically are of three types. One is a trapezium, and then you have a parallelogram, and then you have a kite, right?
Yes, ma'am.
So trapezium means there are only two sides which are parallel. So in parallelogram, the four sides, opposite sides are basically parallel, and in a kite, adjacent sides are equal, but they all are quadrilateral. Then further, this parallelogram is of three types. It can be a rectangle, it can be a rhombus, it can be a square. Now, rectangle means opposite sides are equal, right? And also one corner angle is 90 degree. That also we need to show. Otherwise, it can be something like this also where the opposite sides are equal, right? But it's not a rectangle. Okay, when we come to rhombus, so it's something like this. So we have to show that all the four sides are equal. Now, this is common for square also. All the four sides are equal, right? So this is not enough for a square. Then in addition, we have to show that one corner angle is also 90 degree. Then it becomes a square. So that means you only have to deal with sides. There is no, you don't have to go to angles here in this question. Understand? Rida, is that clear? Hamna, Rida, always on mute. It's not, okay, anyway. Right. So, okay, coming back to the question. See, it's already given that it's a parallelogram, isn't it?
Yes, ma'am.
Okay,
So its opposite sides would already be equal.
yes. In a in the parallelogram A B C D, right? So AB will be equal to what is the other side? CD, okay.
CD.
And AD will be equal to BC. Why? You can write the theorem that opposite sides of a parallelogram are equal. Okay. So the given condition is already used. It's always used in the question. So first thing we have got, you can give it some name. Equation number 1. Okay. Now opposites are equal. Now you have to show that adjacents are also equal, and then you can combine the two, and then you will get all the four sides equal. So you can use the theorem of circle that the tangents which are drawn from an external point are equal to each other, right?
Yes,
So this is just drawing again A, B, C, D. Okay, this is now I named it A, B, C, D, and these were the points P, Q, R, S. Okay. Okay, there's a circle here which you can draw. So, okay, only once I'm writing the theorem, so no need of writing again and again. So, how to write? Since the length of the tangents drawn from an external point are equal, right? So we have mentioned the theorem. Now, therefore, so we can write all that AP will be equal to AS. Okay. Then you have BP equal to BQ, right? Then you have C, okay, BP, then you use CR this side. So CR is equal to CQ. Is that okay? And then use DR is equal to DS. Okay, so you'll understand why I'm writing like this. So these are like 2, 3, 4, and 5. So now you add them, adding 2 plus, right? Adding 2, 3, 4, 5. So what you get? You get AP plus BP plus CR plus DR, right? Equal to AS plus BQ plus CQ plus DS. Okay, so AP plus BP, if I just combine together, so I get AB, and then CR plus DR will give me CD is equal to, now AS plus, okay, this is AS and this is BQ. Okay, so that means you have to add AS and DS together, right? So first of all, you can write them if you want. So AS plus DS. So here basically this way I'm clubbing, okay? And in the next step, then I'm clubbing this BQ plus CQ. So AB plus CD. Now AS plus DS, that becomes your AD. And BQ plus CQ, that becomes your BC. Okay. Now what was the first? That AB is equal to CD and AD is equal to BC. I'm just writing here that AB is equal to CD and AD is equal to BC. Okay. So we can just replace them. In place of CD, we can again write AB. And so I want actually adjacent sides, right? So AB and then I want BC. So I can replace this AD. Is that okay?
Yes.
Because I want adjacent sides. So I'm just keeping this side and I'm keeping this side, right? This is AB and this is BC. So the other things I'm replacing. So AB plus, now in place of CD, I can again write AB. And in place of AD, I can write BC plus BC. So this I have used first equation. Is that clear? So twice of AB is equal to twice of BC. 2 to cancel out and I get AB is equal to BC. Right? Which you can call equation number something next, 6th. Yeah, everybody is on mute. Why? This was your equation number 1. Am I audible to everyone?
Yes, ma'am.
Okay. Okay, so now you combine result 1 and result 6. So how do you combine? You start from any equation. Let's say I start from 1. So AB is equal to CD, right?
Yes.
Mm, no, I think I should start from here because C. Anyway, so AB is equal to CD. Then from 6th, my AB is actually equal to BC. So I can write BC here, right? And then again from here, my BC is equal to AD. So this way, if I just join 1 and 6, so I get all the sides equal. So this was your rhombus A, B, C, D, right? So I have got AB is equal to BC is equal to CD is equal to AD. So all the four sides are equal, right? So A, B, C, D. Yeah, so here I'm just, joining. No, joining from, you write from 1 and 6. Basically from 1 and 6, I'm getting this thing, okay? This relation. So ABCD is a parallelogram with all the sides equal. And therefore it is a rhombus. Hamna, is this understood? Yes, written, Harsha.
Yes, ma'am.
So is there any confusion here where I'm combining 1 and 6?
Uh,
Sorry, your voice is breaking.
Ma'am, like if we stop at 6, it will
Hmm.
also be correct, right?
AB is equal to BC. Yeah, it is correct. Obviously, it is correct because we have all, like in the first, we have already shown that opposite sides are equal, right? And
Yes,
here
ma'am.
I have shown that the adjacent sides are equal. So basically, I'm just concluding the result that if I combine the two results, so the meaning is that all the four sides are equal to each other, right?
Yes, ma'am.
So I'm just concluding both the equations. That's it.
Okay, ma'am. Yes, ma'am, then.
Okay. Okay, so there's a figure also here. We insert it. So a triangle ABC is drawn to circumscribe a circle, okay, of radius 4 centimeter. So radius means OD. So if I write given, so OD is 4 centimeter, right? Okay, such that the segment BD and DC into which BC is divided by the point of contact D are of length 8 centimeter and 6 centimeter respectively. So anyway, it is just given that D is the point of contact, right? So the line segment the line segment BC is actually divided into two parts. So one part is your CD and the other part is BD, whose lengths are already given in the question. This is 6 and this is 8. Find the side AB and AC. Okay, so to find AB and AC. Understand? Okay, so we need to do some construction here. We need to join everything. So you join this AO, then you join CO and also OB. So join OA, OC, OB. And we can name these points, give these points some name where it is this point of contact of the tangent. So I'm just calling it EF, right? Okay, solution, because we have to find it. Mm. Okay, if we use the theorem that the length of the tangent from an external point is equal, right? So CD is 6, so that means CE is also 6 centimeter.
Yes.
Yes, so like we can write it properly. How? Um, length, since length of the tangent from an external point are equal. So therefore we can say that CE will be actually equal to CD and that will be equal to 6 centimeter. And similarly the other one, BF, it will be equal to BD from the same theorem and this is given to be 8 centimeter, right? And also from the same theorem, AE will be equal to AF. So this is not given. Let us assume it's something, let's say X centimeter for the time being. Okay. Okay. So now the sides of the triangle. So in triangle ABC, now what is happening? So your side AB is now equal to BF is 8 centimeter, right? So 8 and AF is X. Or you can write first if you want. So AB side is actually AF plus BF, right? Now AF we have assumed X and BF is 8. So X plus 8 centimeter. Similarly, the other side AC is AE plus CE. So AE is again X, CE is 6. So AX plus 6 centimeter. And the other side BC, so it will be BD plus CD, right? So BD is 8 centimeter. This is 6 centimeter. So 12 into 14. So this one is 14 centimeter. So I have got the three sides of the triangle. Is that clear?
Yes.
Hmm.
Ma'am, can you scroll up it up?
Okay.
Okay, ma'am, thank you.
Okay. See, ultimately, what will happen here? We are getting the sides in terms of X, right?
Yes,
So the one part of the question is to find the value of X. I mean, that this is exactly what we want. We want the length of AB and AC, right? For that, we need to find what is the value of X. So somehow we need to, we need something where we can combine all the sides together and we can work something out so that we can get some algebraic expression to solve X. Getting it?
yes, ma'am.
Okay. So what I will do in this question is, like we can do is, we can break this into three triangles. One is triangle AOC, triangle AOB, right? And triangle COB. Is that okay?
Yes.
Okay, in the construction part, you can also join this. You can write join OA and OF also. Now, because they are also radius, so they will be 4 centimeter and 4 centimeter, right? I think it was 4 in the question or 5. Yeah, 4 centimeter. And OD is also 4. They are radii of the same circle. Okay. Okay.
Yes.
So just try to understand. Don't write. We can find the area of this triangle by half into base into height, right?
Yes.
Similarly, we will find the area of all the 3 triangles by half base into height. Okay. So when I add them, like I add all the 3 area together, so I'll get one expression in x. Okay.
Yes.
Because the base will include x, so somehow then I need equal to, then I need something here, isn't it? If on the left hand side I'm getting something in x, then I need something on the right hand side also to equate it, to form an equation. Understand?
Yes.
So if I just add all the 3, so it becomes the area of the complete triangle ABC. So separately I can find the area of the triangle ABC and then I can equate it. So that will give me an algebraic expression in x which I can solve and get the value of x. Understand?
Yes.
Okay, anyway, one by one, we are going to find all these things. First of all, I will find what is the area of the complete triangle ABC. Then I'll find this area, then I'll find this area, and then I'll find this area. Is that okay?
Yes.
Okay, then I'll combine them together. Okay. Now, because I know only the 3 sides, so I can use Heron's formula for ABC, triangle ABC.
Yes.
Right. So let us find out. So just tell me AB, AC and BC quickly. This was, I think, x
X
plus
plus 8.
8. Yeah, x plus 8. And this was x
X
plus
plus
6.
6.
And this was 4.
14.
So from Heron's formula, or you can say using Heron's formula in triangle ABC, right? So first of all, find the semi-perimeter. This is side AB plus BC and plus what AC and divided by 2, right? All the 3 sides. So this is x plus 8 plus x plus 6 and plus 14 and divided by 2. So that gives me 2x plus 6 and okay, so 8 and 6 is 14 and 14 plus 14 is 28 divided by 2. So you can take 2 common. So it will be x plus 14, right? So your
Yes.
S is x plus 14. Okay. So now area of triangle ABC. So area of triangle ABC. Sorry, area of triangle ABC. So this is square root S into S minus. Okay, now I'm not denoting ABC, so you can write S minus AB. Can I write that? Ultimately, there are 3 sides of the triangle, isn't it? I mean, this is small a, small b, small c are basically the length of the 3 sides of the triangle. So instead of small a, I'm just writing the names of the side. Any problem here? Okay. So S is x plus 14 and use a big bracket now. S minus AB. So S is x plus 14 minus AB is how much? X plus 8. Okay. Then x plus 14 minus x plus 6. Then here x plus 14 minus AC was 14, I think, right?
14.
Yeah. Okay. So this is x plus 14 into, so that becomes x plus 14 minus x and minus 8, right?
Yes.
minus x and minus 6. X plus 14 and then minus 40. Okay. So this is x plus 14 into, now x cancel out. 14 minus 8 is how much? 6, right? Okay.
Yes.
X cancel out. 14 minus 6 will be 8.
8.
And here 14 cancel out and you get only x. Right? Okay. So so basically I'm now getting x plus 14, and if you just multiply this, so 6 into 8 is 48x. Okay. So how will I factorize it? Anyway, multiply it. So x into 48x, right? And plus 14 into 48x, right? Okay, so this becomes 48x square. And how much is it? 14 into 48?
672.
Okay, so this is 672x. Yeah, okay, that's it. I think I cannot do much here, right? So this is your area of triangle ABC. Okay, fine. Now leave it. So again, come back to your triangle. This was your triangle A, B, C, which is divided into 3 triangles now. So AB is x plus 8, AC is x plus 6, and this side is 14, right? And these are the heights, which is D, E, and F. So one by one, let us find out the area. So area of triangle AOC. This is O. So this will be half base into height, right?
We wanted to prove that all those 3 triangles are equal, right?
No, we don't have to prove because mm, okay, why will it be equal? Because yeah, so there's a point you're putting here that why the 3 areas are equal, right?
Yes, sir.
Mm.
So we should
So
also prove
see,
them one
see,
by one.
Harsha, I'm not saying that all are equal. Separately, I'm finding them out. Is there any problem? And then I'm adding. So basically, if I add the area of the 3 triangle, it will become the area of the complete triangle. So I don't need that point that they are equal, right?
Okay.
Like separately, I'm just dividing it. I'm not saying that the 3 parts are equal. They might be equal, but I'm not interested in that. I'm just dividing the triangle into 3 parts. One is AOC, one is AOB, one is BOC, and then I'm adding them together, so they will become the area of the complete triangle.
Okay.
Yeah, that's all. So
If we prove they're congruent, then that would be more easier, right?
congruent. So what will you do there?
SAS, like BO and OC would be the radius. And then the angle
Mhm.
between.
BO and OC are not radius. Radius is OD. This is your circle, isn't it?
Okay.
B is the B is a point which is outside the circle. Okay. Okay, anyway. So height, okay, now before using this, I think you should mention that theorem, because height is the perpendicular. It should be at 90 degree. So you can use the theorem that since tangent is perpendicular to the radius, isn't it? At the point of contact. So what will it give me? So it will give me that your OD is actually perpendicular on BC and OE will be perpendicular on AB and OF will be perpendicular on AC. So now you can take them as height, right?
Yes.
Okay. Like before putting this height, you should show that they are height actually. So area of triangle AOC, half base into height. Half into base will be x plus 6 and height will be OF, right? Or you can write AC first and then you can put values. So half into x plus 6 and into OF is 4 centimeter, right? Radii of the circle. So this is also centimeter, so that becomes centimeter square. So 2 cancel out, so it will be 2 into x plus 6 centimeter square. So 2x plus 12 centimeter square. Is that okay?
Yes.
Okay, now come to triangle AOB. Okay, let's do it here. So area of triangle AOB. So that is again half into base into height, which is AB into OE. So this is half. AB is x plus 8. OE is again 4. This is centimeter. This is centimeter. So 2 cancel out, again 2 into x plus 8 centimeter square. 2x plus 16 centimeter square. Now BOC. So area of triangle BOC is half into BC into OD, right? So that is half into 14 centimeter and OD is 4 centimeter. So 7 into 4 is 28 centimeter square. Is that okay? Now we can just combine everything. So area of triangle ABC is equal to area of triangle, what was that, AOB plus area of triangle AOC plus area of triangle BOC, right? Okay, so area of triangle ABC I have just found. What was that? 48x square plus 672x. And which is in under root. Okay. Now this was AOB 2x plus 16, 2x plus 12 plus 2x plus 12 and plus 28. So everything is in actually centimeter square. Yeah, this is also in centimeter square. So the units will get cancelled out. Am I right?
Yes.
No, one.
Ma'am, 1 centimeter.
It should remain. Yeah, it will remain because I have my x inside, which will be in centimeter, right? Anyway, my mind is not working. I'll think about it later. Just solve for x right now. So 48x square plus 672x and square root is equal to, so 2x plus 2x, that becomes 4x plus, now you add them, 12 and 16, right? So 8 and 2, 10 and 6, 3, 4, 5, 56. Am I right? Yeah.
Yes, ma'am.
Okay, now square both sides. So I get 48x square plus 672x is equal to 4x plus 56 whole square. So I have to remove the square root. So 48x square plus 672x plus, now this is a plus b whole square, right? So
Yes, ma'am.
sorry, equal to a square plus b square plus 2ab, 4x into 56. So 48x square plus 672x is equal to 4 and 4, 16x square plus, how much is 56 into 56? 36, 33, that becomes 30, 8, 6, 3, that is, I think 3136. Please
Yes,
check
ma'am.
the calculation. Okay, so that is 56 into 8. 6 into 8 is 48. Carry 4, 540, 448. 448x. Yeah. Okay, so 48x square minus 16x square. How much I get? 8 minus 6 is 2. So I get 32x square, right? Plus, now 672 minus 448. So 12 minus 8 is 4. Then I get here 6 minus 4 is 2. So I get 224x, right? And minus 3136 is equal to 0. So let us try to take something common here. Okay. So see, like if you are not able to see what you can take common, so start taking 2. One by one you can take, right?
We can go with 4, right?
We take 4. Okay, if you think 4 is there. So 4 into 8 is 32, right? Plus 4 into 5 and then 24. So 656x minus 4 into 7 is 28. Then you have 33. 4 into 8 is 32, 16. Okay. Okay. Now again you can take 8,
4.
4. Okay, let's take one more 4. So 4 into 2x square, 114x minus 4 into 1 is 4, 38. 4 into 9 is 36, 24, 6. I think again I can take 1, 2 common, right?
Yes, ma'am.
Okay, so this will actually become 0, it will go in the denominator. So now I'm taking 2 common. So x square plus 7x minus 2 into 9 is 18, then 16 is 2 into 8. Okay, so it has become, quite simple now. X square plus 7x minus 98 is equal to 0. So that's a quadratic equation. So now you factorize 98. 2 into 4 and 9, 7 into 7, 7 into 1. Okay. Yeah, so I can take 14 and 7 combination, right?
Yes, ma'am.
So x square plus 14x minus 7x minus 98 is equal to 0. So x plus 14 minus 7. So x plus 14, right, is equal to 0. So x plus 14 into x minus 7 is equal to 0. So that will give you x is equal to minus of 14 and x is equal to 7, right? Now because x is what? X is length, which cannot be negative, right? X is length, it cannot be negative. So therefore, x is equal to 7. OMG. Now your side AB, which was x plus 8, so obviously in centimeters. So that becomes 7 plus 8 centimeters, and that becomes 15 centimeters. Then your side AC was x plus 6 centimeter. So that is 7 plus 6 centimeter, and that becomes 13 centimeter. See, the question is lengthy, but it's not that difficult, right?
Yes, ma'am.
Yeah,
For how many marks this would come?
yeah, it's a long question. I mean, it will come in 4 or 5 marks at least. 4 marks I can count. There are a lot of concepts, right? Solving a quadratic equation, then you are using Heron's formula, algebraic expression you are solving, and many concepts, 2, 3 theorems you are using. So I think the last question, can we take it in the next class, or let me see what is the question. Okay. Okay, I gave you some hints. Let's take it. Question number 15. Sorry, 13, yeah. Okay, prove that opposite sides of a quadrilateral circumscribing a circle. That means quadrilateral is outside the circle, right? Okay. Subtends supplementary angle at the center of the circle. Oh God. So you have a circle. Mhm. Okay. Then you have quadrilateral. So, I mean, don't make it like a rhombus. Just any quadrilateral you can draw like this, right? Let's say this is a quad. No, no, no. It should touch the circle. Wait. It should circumscribe the circle from, that means from all the 4 sides, it should touch the circle. So I can take, 1 point if I take very close. So I get a tangent like this, right? And then you can draw one tangent like this. So it's not a parallelogram, right? It can be of any shape. And this is the center O. So prove that the opposite sides of a quadrilateral circumscribing a circle subtends supplementary angle. Now, what are the opposite sides? AB and CD, right?
Yes, ma'am.
So if you join these 4 point of contacts, so basically join them. Now, opposite sides of a quadrilateral subtends. So if I take the side AB, so which angle it is subtending at the center? It is subtending this angle. I mean this angle. Got it?
Yes.
Similarly, the side CD is subtending this angle. this one. So you have to prove here that angle AOB plus angle COD is 180 degree. And similarly for the other sides, so angle AOD and plus angle BOC is 180 degree. This you have to prove. And you can write whatever is given here. So ABCD is just a quadrilateral. You can say, right? Is a quadrilateral. Okay. And you can write here itself. So which touches the circle at point, give it some name, PQRS, at point PQRS. So this is how the quadrilateral is. It is touching the circle at PQRS. Okay, so let us do it quickly. Proof. So this was the construction which I have already done. This join, this OP, OQ, OR, and OS. This was the construction in this question. I think I should name them. It will become a bit simple. Instead of writing, just write, 1, 2, 3, 4, 5, 6, 7, 8. Just 1 minute. My next student is coming. I'm just telling her to wait. Yeah, Jesslyn. Yeah, Jesslyn, if you can hear me, please wait for 5 minutes. I'm just finishing one question, okay? Okay. Let me prove two triangles congruent. So I'm taking triangle AOP. Can you see that? And triangle AOS, right? So AOP is this, and what I'm taking AOS is this one, right? So adjacent triangles I'm taking. Let us try to show them congruent quickly. So I can say AP is equal to AS from the theorem that you can write. Tangents from an external point are equal, right?
Yes.
Okay, then one side is common. AO is equal to AO, which is common here. And yeah, and OP is equal to OS because radii of the same circle, right?
Yes.
So by SSS, the triangle AOP is congruent to triangle AOS, right? And what will it give me? So it give me by CPCT that angle 1 is equal to angle 8. Okay.
Yes.
And the rest you can write similarly. So no need to do. So similarly, what I'll get angle 2 is equal to angle 3. Then I'll get 4 is equal to 5. And I'll get 6 is equal to 7. Yeah.
Yes.
So mark them 1, 2, 3, and 4. Now just add them. No. 1, 2, 3, 4. Yeah, okay. No, I'm not adding them. Just mark them 1, 2, 3, 4. If I just add all the angles, right? So the sum has to be 360 degree that I'm using here. So you can say using angle sum property. Just 1 minute. Zeba, can you just wait for 5 minutes? I'm just starting, okay? I'm just
Yes, ma'am.
finishing the question. Okay. So using angle sum property of quadrilateral. So sum of all the angle has to be angle 1 plus angle 2 plus angle 3 plus angle 4, angle 5, angle 6, angle 7 plus angle 8 is 360 degree, right? Okay. So what is the relationship? So 1 and 8 are equal. So you can just club them quickly. So 1 and 8 make one pair. then 2 and 3 just make pair here, 2 and angle 3, 4 and 5, so angle 4 plus angle 5 plus 6 and 7, so 6 plus angle 7 is equal to 360 degree, right?
Yes.
Okay, now you can replace. So 1 at least you can replace. So here you replace 8, then you replace 3, you replace, just 1 minute. I need AOB, let's say, which is AOB. So 1 and 2 I have to keep, right? And
Yes.
7, no, and 5 and 6 I have to keep, right? So I need this complete and I need this complete. So 1, 2, 5 and 6 I have to keep here. Understand?
Yes.
1, 2, 5, 6 I'll keep. So that means I'll replace 4 and I'll replace 7. Okay. So angle 1 plus, now angle 8 is equal to angle 1. So angle 2 plus angle 3 was equal to angle 2. So that becomes 2. Similarly, you replace 4 by 5. Okay. And here angle 6 plus angle 6 is equal to 360 degree, right? So
Yes.
if you take 2 common, that becomes angle 1 plus angle 2 plus angle 5 plus angle 6 is equal to 360 degree. And then angle 1 plus angle 2 becomes your AOB, and 5 and 6 become COD. This 2 will come here, and then angle 1 plus angle 2 and angle 5 plus angle 6 is 180 degree, and that becomes angle